Welcome students and welcome to my YouTube channel. Today we will discuss curvature, which is the topic of the differential geometry BSc level. The curvature of a curve at any point is the arc rate of rotation of the tangent to the curve and is given by k is equal to dt by ds, where dt by ds is the curvature vector and is perpendicular to the tangent vector t. Now k is equal to k, you can say that k is equal to k mod, which is equal to dt by ds. So here we only substitute k is equal to dt by ds and also put mod on this, now which is equal to mod of curvature. Now we will discuss curvature in a figure by figure, like this. I take xyz plane, then I draw a curve, and I draw a curve. So you can draw a curve anywhere, everywhere in xyz plane. So here I draw a curve like this, then I take a point P, and I draw a position vector of P, which is equal to r of t with respect to the origin O. Now I take another point Q, which is which is at the neighbor at point P, neighboring at point P, and here I draw a position vector r of t plus del t with respect to the origin for the point Q. Now then I draw a tangent line with respect at point P. So here the unit tangent at point P is t. Now here also I draw a tangent line like this at point Q, and here del s is the distance between point P and Q. Now del theta is the angle at the point Q and theta is the angle at the point O. So here you can see that the curve, so we as I discussed about this curve, so here the curve, we say that, so this figure is related with the curvature. As I extend this curve, then it will be it will be a circle, and after that you can see that this is a curvature. This is simply a curvature. This curve is simply a curvature. Now here we will discuss some parts of the curvature, like these: radius of curvature, center of curvature, circle of curvature. I draw different types of curves. You can see that the first curve, and the second, and so on, and also the last curve. Now you can see that the bending of the first curve is so less. Also onwards you can see that the bending increase more and more, and at the last you can see that the bending is so greater. So here the radius of the curvature is so small, and you can see that as the bending of the curvature, as the bending of the curve is will be greater than the curvature is so much, is the curvature will be larger and larger. So you can see as the you can derive a relationship between radius of curvature and also curvature. So here is the mathematical relation between radius of curvature and curvature is inverse. As the radius of curvature is here is small, and the radius of curvature, as you can extend it, then it made then then a circle will be made from this curve like this. So here you can see that the center will be at this point, and then you draw a radius from this. So the radius of this circle is larger and radius here is smaller. So you also derive a result, and also derive a relationship between radius of curvature and also curvature. Here is the curvature is so smaller, and here is the curvature is so larger. So from this we get a result that curvature is inversely related with the radius of the curvature. Now curvature is denoted by k, which we pronounce like kappa, and radius of curvature is denoted by rho. Now we will derive also a result for the rho. As you know that rho is equal to 1 by k, or k is equal to 1 by rho. Here we can also say that k is equal to k mod. We also k mod equal to theta prime, and here we substitute the value of the k. The mathematical value of the k, which is equal to dt by ds, and also put a mod on this. So we shift ds to the numerator and we take a result like this, ds by dt. So here rho is equal to ds by dt. Now here are some examples about the curvature and also radius of the curvature. Find the curvature and radius of curvature to the curve. This is given like that at any point. So solution is equation of the unit tangent is, as you know, simply t is equal to r dot by r dot mod, and you know that r dot is the special case of the derivative, which is so the derivative with respect to t is called r dot. So I simply tagged a derivative with respect to t here, both sides, and then as you know that as constant, so here only we take a derivative of cos t, sin t, and bt, t. Now the result will be like this, minus a sin t plus a cos tj and plus bk. Now I take a mod on this as I need it. So here you know that the modulus function tell us that here minus a sin t whole square plus a cos t whole square plus b squared. So here and also a square root on it. So here we take a square from this, a square common from these two. So here it will remain a square equal into sin square t plus cos square t and plus b square. So here ijk component are show direction. So here we can't take ijk component. Now sin square t plus cos square t equal to 1. So here we will remain only a square plus b square under the root, square root or under the roots. Now here after this we will substitute these two terms here in this mathematical relation. So as you know that curvature is equal to dt by ds, and here the chain rule will be used as the other term dt is mentioned here. Now as after this we take a derivative on this with respect to t, as here we need a result of this and also this. So take a derivative with respect to t on this this mathematical relation. Now as you know about better about derivatives, here under root a square plus b square is constant. So here we doesn't take a derivative on this, so only we take a derivative on the upper function, and here we get a result like this. Now as you know that k is equal to dt by dt into dt by ds. So simply first of all I'd derived result for dt by ds. So you know that since ds by dt equal to s dot as I take a derivative with respect to t, so we can say now as s dot equal to r dot mod. Now as you know that r dot mod equal to under root s square plus b square. So here we can reverse it, and here dt by ds equal to 1 by under root s square plus b square. So here we only substitute the result of these two terms. So from this we take we get a result like this. After simplification we take a result like this, and then I take a mod on this k for finding the mode of the curvature. So and you know about modulus function formula as a minus a cos square t plus minus a sin t whole square, and also a square root on it. Now after that we take common a square from this, and then we will remain a cos square t plus s plus sin square t, and you know a cos square t plus sin square t equal to 1. So here we left only under root a square. So here s square and square root will be cancelled, and here we will remain only a term a. So here the mode of the curvature. Now radius of curvature, as you know that the relationship between curvature and radius of curvature is inverse like this, which is equal to rho is equal to 1 by k. So here we only reverse it. So here this is the radius of the curvature, as you know. So we can separate it as like this, a square by a plus b square by a. So here and a square will be cancelled, and here only a term will be left. So now after that example number 2, find the curvature and radius of the curvature to the curve. This is the curve, and the point is mentioned here, t is equal to 2. So here this is your homework, you do yourself, and then you share me answer of this curve in my comment box. If you have any difficulty, then you can then you can share, then you can tell me in comment box. So please, if you like the video, so share, subscribe my channel, and press the bell icon so you can receive another notification of my another videos. So please take care of yourself, and okay, take care, goodbye.